Okay, nonlinear systems of equations. This is part 2 of the last notes, so applications of nonlinear systems of equations. So before we begin, I want to refresh your minds on what a linear function is. We can have 3 types of linear functions. We can have one that is a diagonal line, and this is the one that should look the most familiar from Algebra 1 because it uses that equation y is equal to mx plus b, where m is the slope and b is the y-intercept. And then our linear functions could also be horizontal lines where y is equal to the y-intercept, or vertical lines where x is equal to the x-intercept. This is important to note in case when we get to part of the problem and it mentions what type of linear function this is, diagonal, horizontal, or vertical, you'll know how to write that properly. So let's look at the example. The graph shows the height y in feet of a soccer ball x seconds after it is kicked from the base of a hill with the initial velocity of 33 feet per second. The linear function represents a hill with a constant slope. Part A, write a system of equations that can model the situation. Use the model y is equal to negative 16x squared plus v naught x plus h naught for projectile motion. Keep in mind that right here, that v sub 0, we say that is v naught, N-O-T, v naught. This is the initial velocity. And then the other one, that h sub 0, is h naught, N-O-T, the initial height. So in order to write our quadratic function, we have to use that model of y is equal to negative 16x squared plus v naught x plus h naught. And we can find those values in the problem. So initial velocity v naught, if we look here, it says the initial velocity is 33 feet per second. So on the line for v naught, I'm going to write 33. And then h naught is the initial height. Well, if someone is kicking a soccer ball, the soccer ball is on the ground, which means the height is 0. There is no height. It's on the ground. So I would write 0, which means my quadratic function would be y is equal to negative 16x squared plus 33x plus 0. Again, you guys know that you don't need to put plus 0 at the end. I am just doing this for the sake of the notes so you can see where those numbers went. And then for our linear function, it says the linear function represents a hill with a constant slope. Well, let's say we can't remember what constant slope means. We could go over to our graph since it's provided to us, and I can look at this linear line here. Okay, and notice it also gives us 2 points, which means from those 2 points, we're able to find the slope, so we're able to write the equation. Okay, so I'm going to zoom in over here. So we're going to label this first point 0, 0 as x1, y1, and this point 2, 2 as x2, y2. So I'm going to do my slope, m is equal to y2 minus y1 over x2 minus x1, which means I have 2 minus 0 over 2 minus 0, which is 2 over 2, which is 1. And then I need to find my b value, that y-intercept. Well, if I look at my line crosses this y-axis at 0. So b is equal to 0. So if I was to translate this into an equation, this is y is equal to mx plus b. So I have y is equal to 1x plus 0. But I don't really need to write the 1, and I don't need to write the 0. So this is just y is equal to x. This is going to be my equation for the linear function. So y is equal to x. Part B says, how long after the ball is kicked does it hit the hill? Okay, so how long means we're finding time. And if you go up to the problem, time is x, because it says x seconds. So that means we only need to find x. Only need x. And since on the front side of this, we were solving these nonlinear systems of equations by setting them equal to each other, because they were both equal to y, we're going to do the same thing here. we're going to take this y equals to x and take this x and plug it into the y up here. So that means I have x is equal to negative 16x squared plus 33x. Since I have a squared, I need to get this equal to 0. So this is the same as saying negative 16x squared plus 32x equals 0 because I subtract the x over. Then I can factor by taking out a GCF, and I can take out a negative 16x, and I'm left with x minus 2 is equal to 0, which means I have negative 16x equals 0, which means x is equal to 0. And I have x minus 2 equals 0, which means that x is equal to 2. Well, this is time, okay? Notice that if we look at our graph here, we have our first second at 0 seconds. Well, 0 seconds is when the ball is still on the ground, okay? So we can't use that one because that's just the starting value. But then x is equal to 2 seconds is where this person here, we have a little person, here's the ball, they kick it up, they go back down, and then boom, it hits the hill again. It's going to hit the hill at 2 seconds. So since we have our answer here of x equals 2, and we're dealing with a word problem, we have to write a sentence in order to answer this. So we would say the ball hits the hill at 2 seconds. And that would be our answer. Okay, last example. Says a juggler tosses a ball into the air, which follows a parabolic path. The ball leaves the juggler's hands 4 feet above the ground and has an initial velocity of 20 feet per second. Someone shoots an arrow horizontally from a height of 8 feet. Write a system of equations that can model the situation. So part A says use the model y is equal to negative 16x squared plus v naught x plus h naught. Remember, v naught is the initial velocity. So I'm going to scan my word problem. I'm going to find the words initial velocity, and it says initial velocity is 20 feet per second. So I'm going to write 20. Then h naught is the initial height. And so I'm going to look up here and it says, okay, a juggler tosses a ball in the air. The ball leaves the juggler's hands at 4 feet above the ground, which means the initial height of where these balls are is 4 feet above the ground. So I'm going to write 4. And then I'm going to take those numbers and plug it into the model, and that is going to give me my quadratic function. So y is equal to negative 16x squared plus 20x plus 4. And then in order to find my linear function, it says that someone shoots an arrow horizontally from the height of 8 feet. Well, if someone shoots it horizontally, we know a horizontal line is going to go through y. So this is going to be y is equal to, and then whatever that y-intercept is, so height of 8 feet. So y is equal to 8. Then part B says the arrow hits the ball on its way back down to the jugular. When does that happen? When is time, and time is going to be our seconds, which is x. So same thing as the last one, I'm going to take this 8 and plug it into the y up here because they're both equal to y. So I have 8 is equal to negative 16x squared plus 20x plus 4. I need to get this equal to 0, so I'm going to subtract the 8 over. So negative 16x squared plus 20x minus 4 equals 0. And then before I try to factor this, I'm going to see if I can take out a GCF. And I can take out a negative 4, and I'm left with 4x squared minus 5x plus 1 equals 0. And then I'm going to have to factor this part right here by doing the AC method. So I need two numbers that multiply to 4, because that's A times C, but add to B, which is negative 5. Okay, so it's going to be negative 1 times negative 4, or negative 1 plus negative 4 to give us negative 5. So then that is the same as saying 4x squared minus 4x minus 1x plus 1 equals 0. We can forget about that negative 4 because when we get to the end and we set everything equal to 0, negative 4 equal to 0 doesn't exist. We don't need to worry about that. So we're just dealing with this part here. I'm then going to do factor by grouping and take out a GCF from each of them. So the first one I can take out a 4x and I'm left with x minus 1. And since I want my parentheses to match, I'm also going to take out a minus 1, so I get x minus 1, which means I have the factors 4x minus 1 times x minus 1 equals 0. And then I'm going to take these and set them separately equal to 0, which means I have x is equal to 1/4 and x is equal to 1. Now, this is where it's important to go back to the problem. The problem says the arrow hits the ball on its way back down. When does this occur? So if this is our graph, right? So here's the juggler, tosses the balls up, and the balls are going to come back down. And then an arrow is going to go horizontally through this. That means the arrow is going to hit it twice. It's going to hit the ball on the way back up, so at 1/4 of a second, and then it's going to hit the ball on the way back down at 1 second. Since it only wants on the way back down, we're only going to pay attention to the 1, so our answer is going to be 1 second. So for our sentence, we would write the arrow hits the ball at 1 second on the way back down. Okay, that information is key to the problem, so we can't just say the arrow hits the ball at 1 second. No, the problem is saying on the way back down, so we have to say the arrow hits the ball at 1 second on the way back down. Okay, and that's going to be our answer.